Back there, this is yet another video from UB's lab, and in this video we are going to have a look at our project number 47, which is solar powered motion sensing night lamp. Well, in this particular project we are going to see how we can use a system of transistors and sensors to make a solar powered motion sensing night lamp. Well, from the name itself you can get an idea of what exactly are we going to make today. So this thing is going to be powered by solar, and is this is actually going to be powered by solar panels, and it will also have a motion detection, which means motion sensing night lamp. So this night lamp is going to function only when there is motion at the night time and will stay off during the daytime. So let us have a quick review at the components that we require for making this. So the first thing that you need for any solar panel project, any solar lamp project, as you have also seen in the previous video where I made a solar night lamp which works for more than 12 hours, and that thing also used this TP4056 module. So this is basically a 3.7 volts lithium ion battery charging module, and it actually has a overcharging over discharging protection feature with itself. So what it does is actually it prevents the battery from overcharging and over discharging. So that is pretty much necessary when we are actually having like a lot of sunlight in the daytime, so we have to prevent the battery from overcharge also. The next thing we are going to require is obviously the solar panels, and these 5-volt solar panels are actually required for charging the battery. So when I say a solar panel, so this is actually something that gives me a voltage of 5 volts DC, and this voltage I require for charging this thing right here. The TP4056 module will actually require the 5 volts input for charging the battery, which is the 3.7 volts battery. So that is the thing, and the next thing we require is our LED lights. So these LED lights are actually the thing that we require for illumination. So these are going to be the output, these are going to be the load for the complete system that we are going to make. So these LED lights can like vary anywhere from 2 LEDs to 10 LEDs, because this system that we are going to make is like having a maximum current limit of 300 mA. So between this current limit you are free to add any number of LEDs which are working on 3 to 4 volts DC. So that is the specification for this circuit. Next we require a lithium ion battery. So basically when we are using lithium ion batteries, we need to take care of its capacity, like the capacity part I will be telling you later in the video. So we are choosing lithium ion batteries because these batteries are the most efficient ones, and also have a sustainable life cycle, or we can say these batteries actually will work best in our case because there will be quick recharge, and these batteries are also lightweight, so we can even hang this lamp anywhere. So the next thing we require is a part of our circuit, and it's going to be a 9012 transistor. This is actually we're going to work as a switch between our circuit and the solar panel. So we'll talk more about that ahead in the video. And next we need a TIP122 transistor. This is basically a Darlington transistor. What that exact thing means, you don't need to actually know about that, but we can actually like call it as a power transistor, because it actually provides a lot of current as compared to other transistors. We'll also talk about it more ahead. The next thing and the most important component is the PIR sensor, which is actually nothing but passive infrared sensor. So this is going to be the motion detection part of our project. So this will actually detect motion, and when it detects motion the lamp will turn on. Actually this sensor is not like much expensive, but it is like really interesting to work with these sensors. So we are going to use one of these PIR sensors, and we are also going to use some time, like we have an option to adjust the timing for which the LEDs will stay on, so we are also going to use that. Next, we also require some resistors, because as we are dealing with some LEDs, so LEDs always work with resistors. Next thing, we also need some brain, obviously, because you're going to deal with electronics, and you might not want to deal with electronics unless you know basics about it. So the next thing we are going to speak about, sorry for the dog barking, this is actually the algorithm. So what exactly we are going to we are going to head towards. So an algorithm is very like important when you are designing some customized project, because this one is actually customized as per my needs, so you can also customize it for your needs. So actually, when I talk about an algorithm, I mean, what do I expect from my project? So the first thing I expect is it should like work with solar panels. And what I expect next is that I require this lamp to stay off at the night time. So I won't expect this lamp to turn on in the daytime randomly, because see, it won't make any sense if the light is turning on in the daytime. So I want it to, so when the lamp is in the charging position, which means when it is having charging, when it is receiving sunlight at the daytime, so it should actually turn off during the daytime at the day. So that is the second requirement. And the third thing I require from this lamp is that it should actually get turned on when there is motion. When the motion is detected, I require the lamp to turn on. So these are basically the requirements I need to fulfill from this lamp. So once you have made this requirement chart, or the algorithm in which your device is going to work, so you come to the question which is most important, and that is, पहले क्या करें? I mean, सबसे पहले, do we need to work for the solar part? Do we need to work for the turning off at the daytime, or do we need for the like motion detection? So the first thing that you need to come towards is like drawing a small diagram which will actually brief your idea, and actually it will make your own concept clear about what you require. So in this small like childish picture drawing, I am not just that good at drawing, so I would briefly explain you all the working of this simple idea. So the thing is that when there is sunlight in the daytime, so these solar panels over here, these are going to receive sunlight, and these are going to provide me some 5 volts, like some voltage at the TP4056 module. So this module over here will simultaneously charge these batteries, like this battery over here, and in the daytime it will also turn off the output supply system, which means it will not give the power supply to the motion sensor when the battery is charging, which means I need such a system which will actually turn this path off, which means it will not provide the power to the sensor only when there is voltage at this point. So for that, we are going to use the S9012 transistor, which is going to work as a bridge between this. So it is actually acting as a checkpoint, which will check if there is voltage at this point. It won't allow voltage to come to the motion sensor. So if it is charging, then turn off output supply. But if the system is not charging, which means if there is no sunlight on the solar panels, only and only then the output supply would turn on, and which means this output supply, it will actually turn on the PIR sensor. When there is power supply established to the PIR sensor, what actually will happen is, see, let us have a small overlook at the PIR sensor. This thing right over here, this will actually receive all the passive infrared radiation from a body, whichever is moving. Like if we are moving in front of the sensor, it will detect the infrared radiation, and it will actually detect that there is some motion happening over here. So this sensor actually has these two presets. If I would like, if I could show you, I would show these small two presets over here, this one and this one. So these two presets are actually, one is for calibrating the calibration of range, and the second one is for calibrating the, I can say, on timing. So the time for which the pin will stay on is going to be changed by these two presets. So you can adjust these, actually these are potentiometers which you can adjust, and according to that these two factors, that is the range and the timing, are going to be adjusted. So when I talk about these, the pins on the sensor, the first thing is over here. You can see this is the negative, this is the positive. You can actually feed the sensor with a voltage of like 3.7 to 5 volts. So in this case, when we are using a lithium ion battery, we are going to select this voltage, because the battery is going to have a nominal voltage of 3.7 volts. So what actually is going to happen is, when there is motion detected, this signal pin over here, this exact pin which I'm highlighting, it's going to be turning to 3.3 volts, and it's going to be called as its high state. Like, if the motion is detected, then we say that the signal pin goes high, and when there is no motion detected, we call it that the signal pin goes low. And actually, when there is no motion, it goes to 0 volts, and when there is motion detection, it goes to 3.3 volts. So that is actually the trigger point for our entire project, and that is the basic thing how we are going to achieve our motion detection. So the signal pin goes high to 3.3 volts DC, and this TIP122 transistor will act as a switch between the sensor and the load. Now you might ask, why do we require this TIP122 transistor, and whatever, all of those, like transistors and all those, which are making this project even more complicated. So actually there's something called as current limiting feature, and actually this is something like a limitation for the sensor. So what it actually happens is, when this 3.3 volts, when I say the signal pin goes high to 3.3 volts, this voltage is actually only 3.3 volts, and it has a very less current. Like, it cannot even turn on a small LED. So we need to amplify this voltage. Actually, we cannot do it directly, so we are going to use a transistor. So what actually a transistor does is, it actually uses this voltage as a threshold voltage for turning on flow between current of its two legs, like we are going to see in the circuit diagram. So when it acts as a switch between the sensor and the load, it takes 3.3 volts as the input, and it whenever it receives this 3.3 volts, it understands that it has to establish current between the between the battery and the load. It will turn on your LEDs. Well, there is a limitation for this sensor as well. Like, it's going to have a maximum current of 300 mA. If you want even more current, you actually have to go to a higher voltage, or even some different transistors. So LEDs, when turn on, there are actually two conditions that are to be fulfilled before the LEDs get illuminated. So the first condition is that it's night, which means that the voltage from the solar panels is zero. And the second thing, that is the signal pin of the sensor, it outputs 3.3 volts, which means the pin goes high, which also means motion is detected. ये आदमी क्या बोल रहा है भाई? आज खुश तो बहुत होंगे तुम, क्यों भाई? मस्त प्रोजेक्ट बना रहे हैं आज, ठीक है? नहीं हो तो सिर पटक लो, कुछ इस तरह से। अगर ये नहीं करना चाहते तो सब्सक्राइब कर लो यार, देरी मत करो। So getting straight to the point, this is the circuit diagram for the project, and it might look a little bit messy, but I'm sorry for the bad drawing, but this would definitely work, and I have installed it at my home. So, well, coming to the circuit diagram, this point we will start from is the, well, I'll just let me choose some different color. Which one should I choose? Which one? Okay, let me take green, because that I haven't used over here. So when the 5 volts comes to this point, well, that doesn't work. Yellow is good. So 5 volts input from the solar panels, this 5 volt directly comes into the, this is nothing but TP4056. Red is always the best. Yes. So when this voltage is input to the TP4056, what it actually does is it will directly start charging the battery which is connected over here. So this battery will receive its power like here over this, we can see the wiring. So this TP will start directly charging the battery whenever there is voltage available from the solar panels. And at the same time, this positive 5 volts rail is also going to the PNP transistor 9012. Now here comes the main role of the PNP transistor. So what it actually does is, when there is power supply coming to this transistor, what it does is it actually doesn't allow the supply of, this is actually the 4.2 volts positive pin coming from the battery over here. So it doesn't allow the power to flow, so there is no connection between this point and this point. So these 2 points are not connected over here when there is voltage at the TP4056 module. When there is voltage at this module, what it actually does is it doesn't allow the current to flow to this sensor. So this sensor is actually off at this time, and it's charging the battery. And the next thing what happens is, when there is 0 volts at the input, at that time only this PNP transistor allows flow of current through it, and the sensor will get its plus 5 volts. And when it gets its 5 volts DC, the sensor will start working, and in case if it detects some motion, it will turn this pin to 3.3 volts, and this voltage will come towards the TIP122 transistor. This transistor we have connected via 1 kilo ohm resistor for safety purposes, and when this transistor will receive a signal from the PIR sensor, it will turn on the contact between these two pins. As you can see over here, I'll highlight it once again. These two pins, so these two pins are actually, one goes to the negative out of the load, and the second one comes from the negative, this one right over here, it comes from the negative of the battery. So the supply between the battery and the output will be established once this transistor turns on, and that is done only via the PIR sensor. And the PIR sensor receives power only when there is no voltage at the PNP transistor. So this is all about how it works. This isn't at all complicated, it's a very simple circuit. And at last I would like to also mention that you can choose batteries, like you can take batteries from 3.7 to 3.8 voltage. This is actually, nowadays you can get cell phone batteries which are ranging from these to this voltage, but the only thing that matters over here is the capacity. Like you can even use these 5000 mAh, you can also use 3000 mAh, but you have to actually calculate the current that your solar panel is actually fetching from the sunlight. So if your solar panel is like 300 mAh, and if you're getting a sunlight of 10 hours per day, so you can, without any problem, you can simply add a 3000 mAh battery. But in the same case, if your solar panels are not going to give you that much of current, if it's going to give you only 130 mAh, then you have to think about your battery capacity. So that is all about the video, and I hope you found it useful. If you found it useful, please hit that like button, and if you want more such videos, hit the subscribe button as well. Thank you.